HPC functions. All right. So this first question here says, determine if it is even, odd, or neither, and explain. Well, I know right away that it's going to be odd, because one of the things that you realize is that if it's a polynomial function and every term has an odd exponent on it, then it's an odd function. The way you can explain it, another way you can explain it, there's a couple ways. You can either graph it and show that it's symmetric about the origin, or you can find f of negative x and negative f of x, and they will be equal to each other. And that's one of the definitions, or determining factors of even and odd functions, or an odd function, I should say. So let's do it that way. -3, and I'm plugging negative x in here, negative x. And you'll notice what happens is, if I'm raising a negative to an odd power, what happens with the negative ultimately?
It stays.
That's right. And so it changes the sign, right? So it's going to be 3x to the 5th, and this is going to be minus x to the 3rd. So all of the signs changed. And what does it do when you take the negative, the opposite of a function? What do you do?
You multiply the whole thing by -1.
In other words, what happens to all the signs?
They switch.
All of them switch. And that's why we know that when all of the exponents are odd, it's an odd function. Okay.
Yeah.
By the way, when all the exponents are even, it's an even function, and it can also have a constant and still be an even function. Okay, do you understand that, or do you need me to explain that? You get that? Okay.
Yeah.
All right, cool. So this next one says, let P be xy, let xy be a point on the graph. Express the distance d from P to the point 0, -1 as a function of x. All right, so this is going to be a distance, and they want you to describe it as a function of x, which means we're gonna write this point as x comma x squared minus 8 instead of x comma y. We're going to use x and x squared minus 8, because that's what y equals. Y equals x squared minus 8. So the distance from point P to the point 0, -1, we'd use the distance formula. And remember, the distance formula is, it's just basically Pythagorean's theorem, right? So it's this. And we're going to plug in the x's and the y's. So the x's are going to be, I'll plug these in as my first point so that I don't have negatives with them. So this is x minus the x coordinate, which is 0. You follow what I'm doing here?
Yeah.
And this is going to be y. Your y is going to be x squared minus 8 minus -1, which is +1. Let me just check to make sure now I'm thinking about it, what the distance formula is. The distance formula is x1 minus x2 squared plus y1 minus y2 squared, right? I'm doing that right, correct? I'm just having a little bit of a moment to make sure that I haven't done this in a year or so. Yeah, so that's it. So then we would just simplify this so that it would be written as a function of x, and it would be nice and clean. So this is just going to be, whoops, that's going to be -7. So we have, let's see, x squared plus x squared. So is a +1 here? It is a +1. X squared minus 7 squared. And you can probably leave it like that. I mean, you could simplify it a little bit more if you wanted to, but I don't know that you necessarily have to, because it didn't ask for anything specific about the form of the function. It just says as a function of x. So I think that that's probably fine. So it says, what
Okay.
is D? What is the distance if X equals 0? Well, if X equals 0, plug in 0 here and here, and the distance is going to be 7. We could do that in our head. This would go away, this would go away. It would be -7 squared, which is 49. The square root of 49 is 7. So the distance would be 7. What is D if X is -1? So if I plug in -1, so D, I'm gonna write D in terms of X. I'm gonna write it like that, D of X. So D of -1 would just be the square root of -1 squared plus -1 squared minus 7 squared, which equals the square root of 1 plus, that is going to be 1 minus 7, which is 6. So that's going to be 36, right? Which just equals 37, square root of 37.
Yeah.
Good. Do you have the answer key for these by chance?
I think so. Give me a second.
Just to make sure, so that in case something was wrong, we can catch it right away, because I'm certainly not perfect with all this stuff. The next thing, while you're doing that, I'll go ahead.
Yeah, they all look right.
Okay, 7 square root of 37. So now it says graph it. So on a graphing utility, so let's go to our graphing utility and let's clear this, and we're going to type in the square root, and be careful with the parentheses here, the square root of X squared plus parentheses X squared minus 7 parentheses squared. See if I type that in right. Does that look right?
Yeah.
And I hit graph. And that's the graph. Which is interesting. It looks like a quadratic. Wait, did I do square root? Yeah, I did. Okay. So that is the graph. And the question says, for what values of X is D the smallest? So you can see that D is the smallest. Your graphing calculator should give you a min. There should be a min option on your graphing calculator. Let me just zoom out and see if I'm missing anything here. I'm actually surprised this looks just like a quadratic, but looking at that equation, I don't know that I would have thought that it was a quadratic. Now I've done it, I'm way too high. What's it look like on your graphing calculator?
I'm pulling it up right now.
Seems like for what values, it says for what values of X is D smallest. It sure looks like 0 to me.
Yeah.
And only 0. And does that make sense? See, if I'm plugging in 1, what's it look like on yours?
My calculator is still like thinking.
Oh, I'm trying to think if I have another graphing calculator. Desmos. Does Desmos have graphing functionality? Oh yeah. Let's try it on Desmos. Maybe we'll be able to see it better. So it's the square root of X squared plus parentheses x squared minus 7 parentheses squared. Yeah, that looks more like it.
Mm-hmm.
That looks more like it. I don't know what I did wrong with this one, punching it in,
Oh,
but I must have done something wrong. I
yeah, it
don't
just
see.
showed up like how it did on Desmos on my calculator.
Yeah, I don't know why it's not that way, because it seems like I put it in right. The syntax seems to be correct.
Mm-hmm.
Oh, you know what? Look, it's because I had to get out of that. It was red. I had to like get all the way to the right, and then I bet you
Oh,
now it's gonna graph. Well, still didn't look, still doesn't look right to me. Yeah, that well, there's something not right about this graphing calculator, unless I'm just too far from it. Unless I'm too far from it and I can't zoom in enough on it to see.
mm-hmm.
But it sure looks like that's the wrong graph. Something doesn't look right about that. We'll stick with Desmos. Desmos seems to be more realistic. So if I wanted to find the min on Desmos, I think there's a way to do that.
Yeah, I don't know off the top of my head. On my calculator, I was just able to find it. And
Yeah,
yeah,
is that it?
exactly that. Yep.
Yeah. So for Desmos, all you have to do is just tap it and it will find it. It's kind of smart. It knows what you're looking for. Now, I don't know how you can find other values. Well, yeah, you just touch it to find what other values are. So you touch on the graph, but
Mm-hmm.
it is smart, and it gives you maxes and mins and intercepts and all that kind of stuff. So there you go. There's the answer to that one. All right,
Perfect.
good.
Yep.
Page 3, it says, given that and that, find and state the domain and range. Okay, so f of g of x. So what I will do is literally just do f of x divided by g of x.
Mm-hmm.
So that equals x squared minus 5x minus 36 divided by x squared plus 4x. And we can, if it factors, which it doesn't look like either one of these will, 6, 12, well, maybe. What's, no, 36 is 6 and 6, or 12 and 3, or
9 and 4.
9 and 4 will work. There we go. 9 and 4. So x minus 9, x plus 4, right? Factoring.
Mm-hmm.
And factor out an x and you get x plus 4. So what's going to happen here is that x plus 4 is going to cancel out, but you have to write, when you do that, you still have to write that the restricted domain, you have to say that x does not equal -4.
Mm-hmm.
So given that, find f. So this is the answer, but you have to make that. So your domain for this is going to be, and also obviously x can't equal 0, right? But
Yeah.
you don't have to really write that, because you can see that. So but that does get considered for the domain. So the domain is from -infinity to -4, union -4 to 0, union 0 to infinity. Got how I did that?
Yes.
And the range is going to be, let's see, for the range, you are going to have a vertical asymptote. You're going to have a hole. Let's see, for the range, probably the best way to do this is to consider your horizontal asymptote for the range. Do you remember how to find a horizontal asymptote?
Not off the top of my head.
So if the degrees are the same on the top and the bottom, which they are, your horizontal asymptote is the ratio of leading coefficients. So your horizontal asymptote is just y equals 1, which means there's going to be a horizontal asymptote on your graph, and the graph won't touch that anywhere. Now, technically it could touch that. A horizontal asymptote could be crossed, but in this case it won't be, because there's nothing, just because I know. the way that these things work. So your range is probably going to be all real numbers except one. Now, one thing we could do to double check that and to see is to actually graph this. So if we look at this on Desmos, it's x minus 9 over 11, x minus 9, let's see, divided by, nope, that didn't work. Let's try this. Parentheses x minus 9, parentheses, divided by x. And do you see how there's an asymptote there?
Mm-hmm.
The horizontal asymptote, like I said, is 1. Now it's kind of hard to tell that on the graph, but I know there is one because of the equation, because of what I did on the equation, finding horizontal asymptotes. I've got a bunch of videos on my website about like graphing rational functions. You might want to go check them out later.
Okay.
And then the vertical asymptote, like we said already, is 0. See how there's a vertical asymptote at 0? And there's a hole, which we can't see on here, but there is going to be a hole. Oh, and that also might give us, that might give us another domain restriction. So that's the other place to consider. Where is that hole at? Well, we crossed out at -4. So if you plug in -4, if you also plug in -4 here into your modified graph, right here, plug in -4 and -4, that's going to tell you where your hole is. Your hole is at -4 comma, what is that? -13 over 3, so or over 4, so -13 over -4, which is 13/4. So there's a hole at -4 comma 13/4. So if I look over here at Desmos at -4, if I go onto the graph at -4, let's zoom in here, -4, that's -4 comma 13/4. See, it's 3.25. But you can't have that point because -4 isn't part of the domain, right? So there has to be an open circle there. And since there's an open circle there, that point is not part of the range. Does that make sense?
Yeah.
So your horizontal asymptote is one thing to look for, and then your holes are another thing to look for in a case like this. So the range for this one is going to be from -infinity to 1, union from 1 to 13/4, union from 13/4 to infinity. Okay, good.
Yeah.
That's actually the hardest one of all of them. These other ones are relatively easy because this is just f of x plus g of x. So you just add them together and you're just going to get a standard polynomial, right? So if I add them together, it's x squared minus 5x minus 36 plus x squared plus 4x. So you get 2x squared minus x minus 36. And that's your function. We'll call it h of x, the sum. And then it says find the domain and range. Well, that's just a quadratic. So the only thing I need to find is the vertex. Remember how to find the vertex easily? -b. It's -b over 2a is your x coordinate. And then you just plug that in to find your y coordinate.
Oh, okay.
So the opposite of b is 1 over 2a. A is 2. You understand where I'm getting these from? Here's your b, here's your a. So your x coordinate of your vertex, v sub x I'll call it, is just 1/4. And your y coordinate of your vertex is plug in 1/4 into the equation, minus 1/4 minus 36. So that's 2 over 16, 1 over 8 minus 1/4 minus 36. So that's minus what, 1/8? That can be 1/8 minus 1/8. So your y coordinate is negative 36 and 1/8. And the reason we need that is because that's going to help us. The domain is all real numbers because it's just a parabola, right?
Yeah.
Domain is from negative infinity to infinity, but the range is going to be limited by your vertex. The vertex, since it's opening up, the vertex is going to be your lowest point. So your range is everything above that. So that's the number that I needed right there to find my range. So my range is going to be including negative 36 and 1/8 to infinity. Again, unless I made a mistake and went too quick, but I'm pretty sure that's right. Now for this one, it's not really asking for the domain and range and everything. It's just asking for f times g of 3. So it just wants you to calculate that. So the way to do this, and I don't think it's of, was it f times or was it f of? Was it composition or multiplication? It's kind of hard, it doesn't really say in there. I'm kind of guessing that it was composition, function composition. But we'll do both of them. If it was f times g of 3, or if it was f of g of 3. F times g of 3 is just f of 3 times g of 3. So just plug in 3 for all the x's and multiply them out, what you get. So f of 3, see if I can sneak this in here. F of 3 is, I'm just going to do this in my head, 9, right? 3 squared is 9 minus 15. So that's negative 6 minus 36. So that's negative 42, right? Negative 42. And g of 3 is 9 plus 12, which is 21. So it's just negative 42 times 21. What's negative 42 times 21? Negative 42 times 21. Negative 882. That would be f times g of x. F of g, oh sorry, f times g of 3. F of g of 3 means you find g of 3 first, which we already found, right? G of 3 was 21. And then we plug that in to f. So what's f of 21? Well, f of 21 is 21 squared minus 5 times 21 minus 36. So take your calculator, carefully punch that in. 21 squared minus 105 minus 36, 300. Unless my calculator made a mistake, or I did. So those are your two answers. I'm not sure which one they wanted.
Okay.
Good?
Yep.
Questions on that? No?
No.
Oh, here we go. Function composition. It says find the domain of the function composition if this equals, if this and this. All right, so the domain of it, so we're going to plug in g into x. We're literally plugging this in to here. So f of g of x is going to be, I'm going to start writing my f of x, but I'm going to leave a big blank for whenever, for the where I see the x. G of x is equal to 16 over x. So I write 16 over x into here. Find the domain. They only wanted the domain of it. So, well, there's two things that can't happen here. You can't, x can't equal 0 because then this wouldn't work, right? And x can't, and this can't equal 0. So we're going to set that equal to 0. We're going to set 16 over x plus 8 equal to 0 to find out what that is. And we're going to say that can't equal, and we're also going to say from this one that x can't equal 0. So this would be 16 over x equals negative 8 -8x equals 16, just doing regular algebra here, and x equals -2. So x can't equal -2. X can't equal 0, and x can't equal -2.
Mhm.
So the domain would be from -infinity to 0, union from 0. Whoops, I did that wrong. -2 comes first. From -infinity to -2, union. From -2 to 0, union. From 0 to infinity. Everything but -2 and 0.
Mhm.
Okay.
Yep.
But you'll notice that -8, it can still be -8. X can still be -8. That doesn't
Mhm.
cause a problem, right?
Yeah.
So that's how you would do that. Write an expression for the following: the area of a rectangle with sides x and y. All right, so the area is x times y. Perimeter of a rectangle with sides x and y. Well, there's 2 x's and there's 2 y's, and you're adding them all together.
Mhm.
Got that? The
Yep.
sum of 2 numbers, u and v, the sum, that would just be the sum equals u plus v. The sum of 2 numbers, u and v. Yeah, I'm gonna guess that's what they're asking for. The relationship of the 3 sides of this right triangle. They said it's a right triangle. So that's Pythagorean's theorem, right?
Mhm.
X squared plus y squared equals 25, or 5 squared. The area of the right triangle in terms of x. Okay, so in terms of x means I'm using this and not this. So I'm thinking of, remember the area of a
Mhm.
triangle is 1/2 base times height.
Mhm.
So we're gonna have to, the base and the height are x and y in this case because it's a right triangle. So, but they want us to write it in terms of x. So what I have to do is I have to turn this, the y, I have to solve the y for x. And I can use this equation to do that because that's the relationship between them. So y equals 25 minus x squared. It's the square root of that.
Mhm.
Get how I did that?
Yes.
So this equals, so now I'm substituting that in, it's 1/2 x times the square root of 25 minus x squared. Good.
Yep.
The volume of a cylinder as a function of the radius of the base if the height is twice the radius. Okay, the volume of the cylinder. So here's my cylinder. As a function of the radius of the base. So here's my radius. If the height is twice the radius, so this height right here is 2r.
Mhm.
So the formula for the volume is it pi r squared? Is it the area of the base times the height? Is that the
Yeah.
formula? So it's pi r squared times the height times 2r. That seem right? So the
Yeah.
volume equals, so cleaning that up, it would be 2 pi r cubed. That makes sense?
Yep.
All right, the volume of a cone as a function of the altitude, if the altitude is twice the radius. So you're gonna have to help me with this formula because I don't know it off the top of my head. What's the volume of a cone formula?
I think it's like 1/3
1/3.
pi r squared height. Yeah.
That sounds about right to me. So this is going to be the radius down here, and they're telling us that the as a function of the altitude. Oh, okay. So this is my altitude A. We'll call it A. If the
Mhm.
altitude is twice the radius, so that means the radius is half the altitude, right?
Mhm.
So there's that relationship that I need right there. The radius is 1/2 the altitude, and they want it as a function of altitude. So we're gonna do, what'd you say it was? 1/3,
Yeah.
1/3 the area of the base times the altitude. Is that what it was?
Yeah.
Pi r squared. Well, r is a over 2 squared. Pi r squared times the altitude.
Mm-hmm. Yeah.
So cleaning this up, that's equal to 1/12, because 2 squared is 4 and 4 times 3 is
Mm-hmm.
12. So pi over 12, put the pi on the top, a to the third, a cubed. Sound right?
Yeah.
And the volume of a box, that's just length times width times height.
Yeah.
Right?
Yeah.
They didn't really give us any more. Length times width times height. Okay. And the volume of a sphere with radius r, is that 4/3 pi r cubed or something like that?
I think so.
I don't actually remember, but it seems, I feel like there might be a 4/3 in there. Pi
Mm-hmm.
r cubed. That seems something like that. I don't know. You'll have to look that one up. I'm not sure about that
Okay.
one. All right. I think that's all the time I have today, unfortunately.
Okay.
Because I got someone else waiting here, but I see that you've got some more. When's
Yeah,
your
I
quiz?
guess tomorrow. I always put extra ones though, just depending on
Sure.
the time we have.
Yeah. And next time, if you ever want me just to skip to one, if you just obviously put them maybe in the order that of importance to you.
Yeah, that's what I did today for the
Oh, perfect. Good. Well, you know what you're doing then. All right. Well, good luck on that quiz tomorrow.